Testing. Alright, today is Saturday, June 14, 2025. It's around midnight. So I have to keep my noise at a minimum, but the topic of today's video will be what to do or what to think about when you write your Lexer for your language. So I have a few bullet points right here. Has 4 points, but let's add one more. That's about why. Why would you want to write your own lecture? The answer is quite simple. It's because you need to write your own, or you want to write your own parser. Then you would write your own lecture. That's the main reason. Now you might say, oh, I don't want to write my own parser, but you want to learn. That's a good reason to write too. Okay, let's add one more question. Let's say why. Okay, why Lexer? What Lexer? What's Lexer? Lexer is basically a tool that scans your string input to your language and returns token. So if you have something like this and an ABC, when it goes to the Lexer, this is going to be turned into something like token number, and then token identifier, and then later these tokens are used by the parser to make your tree or your language or whatever it is. Okay, so pretty simple. Okay, so let's talk about some design perspective that you should think about when you write your lecture. Okay, first of all, design it for failure. I think that's really helpful. Basically, if you hit something like this, right, you don't want your lecture to crash. You want it to keep going, because afterwards you want this -d to be given to the programmer and says, hey, you're doing the wrong thing. Replace it with something that I understand. That's the main reason. Another thing that you would probably want something to represent these kind of failures with like token invalid. So maybe this turns into token invalid, right? It's because if there are a bunch of token invalid, oh my god, then you can join them together and make it one singular invalid token. Okay, now sometimes it also happens that you don't want to fail when you hit an invalid token, right? You probably might tell your parser to be like, hey, you better handle invalid tokens as well. So that's an extra nice thing when you're writing your own parser. On top of that, writing your own Lexer. Yeah, join them. Basically, if you have like nearby invalids, you join them into one invalids. I think that makes sense. Okay. So let's show you that what I'm talking about. Okay. It's basically what you would do is you would reserve something like this, talk invalid, in your enum of token type, and then in your class of token, you, you add a lexem. Lexem means that when you query a token of talk identifier, the lexem will be ABC. Now, why would you want a lexem? Besides the case of token identifier every time is different, is because you can join all the invalid tokens together to make one big invalid token. Okay. The second thing that I want to talk about is think about how you would design or incorporate a way to talk about location in your token. Why would you want to do that? Well, basically, the reason is because the string that feeds in that the user gave you, like this input, you need a way to tell them that, okay, on this line, how many characters from the left is where your errors happen. If you only have tokens but no way to represent it, it is still fine, but when the parser errors out, it's gonna be really weird. What I mean by that is that our parser might error out something like this message. Error failed to match the right parentheses after expression or something like that, right? It's good that it errors out, but the user might not have enough context, or he or she or they might need to spend more brain power to figure out the error. So you would want a way to like point it out to them to make it obvious. Okay, let's probably run some tests for you to see that. Okay, so I have this file, right? And in my language, when I do 1 + 1, the type of this expression is 2. The type is integer. But here I have a floating point type. So this should error out, okay? Now, when it errors out like this, it should tell you the type, but it should also point out the location of the code. That's why you need to incorporate the location into your Lexer. Okay, I'll try running this for you guys. Okay, as you can see here, since I incorporate locations into the Lexer from the start, my compiler is able to tell the user, hey, it's happening on line 3, you need to watch out, change it somehow. And it's true, right? We're on line 3 and this let expression is causing the error. So you need to think about these type of things, okay? Okay. Second thing, or I guess the third thing that I want to talk about is don't skip things like comments, okay? I made that mistake. Right now, like these comments, I just like skip them, right? So I skip these comments so they don't show up on in my like outside tokens, like the Lexer, just skip them away, right? But one thing that's nice when you like incorporate these tokens is you can do something like to do, right? Or you can do something like fix, or I guess warn or something, right? And then later in your compiler development, you can be like, you can, I guess, depends on these tokens and parse these into these AST that tells you how many to-dos you have, how many warns you have, right? How many blah 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 you have. So don't skip any comments, don't skip any aesthetics like spaces. You can skip, right? But like these comments, don't skip them. Yeah. Okay. One final thing is keep it simple. Keep it monotone. So I'll show you. Okay, how do I? Probably this is best. Okay. So this is the code base for my language, the Lexer. So you can see things are very simple here, right? Each function has 2 inputs to it, and they always output an integer. Like, just keep it very monotone. And then in my code base, what I have is I have tiers, right? So if you notice, I have operator here, and then whatever the name is. All of these are called inside handle operators. Okay, same for utility. Utility parent curly comment, it always goes into this function. For example, handle utility, right? These are the functions, 6 functions, right? So by keeping things very monotone, monotone as in same number of input, same type of input, same type of output, I was able to just do this. How many lines is that? About 18 lines for 6 functions, right? So try to keep everything monotone. I think for a lecture, this is a great design pattern. I put a link down to my repository and my file for you to look at it. But yeah, keep things monotone, right? If you have to repeat a few things, that's fine, right? So like here, these are the code to handle the greater than, so greater, only greater, or greater equals, right? And the same thing here. So a lot of these things, they are repetitive, but in a way you can deal with that later, right? if it's not broken and it's relatively simple, you can keep it, right? But try to keep things monotone, and then okay, about the token, the location thing. I have a blog on how you're gonna incorporate locations reporting to your Lexer as well as your parser. I'll put a link down to it, and I'll see you guys later.